Today, we're diving into a superpower that every scientist, business owner, and tech expert uses: data handling. Think about it. Every time you check your steps on a smartwatch or look at a game leaderboard, you're looking at data that has been organized. But how do we get from a messy pile of numbers to a clear picture? Let's break down our mind map and learn how to master the art of data. First stop on our map: organizing data. When you first collect information, it's called raw data. It's unorganized and honestly a bit of a headache. To make sense of it, we start by sorting, arranging it in ascending or descending order. But the real pro move is creating a frequency distribution table. We use tally marks. Remember, we group them in bundles of 5 to make counting fast. This gives us the frequency count, which tells us how often a specific value appears. Add those up, and you get the total frequency. A quick warning for the budding scientists out there. The limitation here is the loss of identity. Once we say 5 students got an A, we lose the specific names of those students. We have the big picture, but we lose the tiny details. Now let's get visual. Pictographs use pictures or symbols to represent data. It's the most fun way to see information. The secret ingredient here is the key. If one apple icon equals 10 apples, that's your scale per symbol. Sometimes we use fractional symbols, like half an apple, to show a partial value. Pictographs are great for younger audiences, but they have a limitation. They aren't very precise for massive or very complex data sets. If you have 1,245 apples, you're going to be drawing icons all day. When accuracy is everything, we move to bar graphs. These are the skyscrapers of the data world. A good bar graph has 3 key features: uniform width. Every bar must be the same width. Equal gaps. The space between bars must be consistent. Proportional. Height. The height represents the frequency. How do we draw one? It's a 5-step process. Start with your perpendicular axes, the X and Y lines. Label your categories. Choose a scale that fits your paper. Draw the bars, and most importantly, add a title so people know what they're looking at. And remember, you can go vertical to show trends over time, or horizontal if your category names are really long. Let's talk about aesthetic considerations. Since we want to create high-quality content, we need to think like designers. Infographics. This is where info meets graphic. It's about making data beautiful and informative. Visual honesty. This is huge. We must avoid misleading data. Keep constant width. If one bar is wider than others, it looks more important even if the value is lower. That's cheating. Avoid 3D distortion. 3D graphs look cool, but they make it hard to see where the top of the bar actually hits the scale. Avoid area scaling. Don't use 2D shapes that grow in both width and height, as it tricks the eye into thinking the difference is much bigger than it is. Final step: graph selection. How do you know which one to use? Use a pictograph for small visual data meant for a quick glance. Use a bar graph for large, precise datasets where accuracy is king. Choose vertical bars when you want to show heights or trends. Choose horizontal bars for rankings or when you have long category labels. Choosing the right graph is like choosing the right programming language. It depends entirely on the goal of your project. And that's data handling in a nutshell. From raw numbers to beautiful, honest visuals. Practice these steps, and you'll be able to tell stories with data that anyone can understand. Thanks for joining us at Videora. Don't forget to check the description for a practice worksheet, and I'll see you in the next lesson. Keep learning, keep growing.